It gives me great pleasure now to introduce Paul Glasziou. Now, I've got a script here to read about Paul, but I'm not going to do that because I know Paul from a long time ago. Paul actually was one of my first tutors when I stepped out of clinical medicine and said, I'm going to sign up and be an epidemiologist, so I'm going to do public health. And I knew it was a little bit about maths and medicine, but I didn't really know very much. Paul was one of my very first tutors, schooled me in a lot of statistics and mathematics, even though Paul is multiply qualified, I think in computer science and in medicine and in general practice and a whole bunch of other things. Has a brain this big and was a fantastic teacher and a fantastic role model. And his career highlights have really been around this area of evidence-based medicine. And if you follow Paul's career, he has held posts at Oxford University, the most prestigious posts in evidence-based medicine, and has really debunked a whole lot of clinical furphies, treatments that didn't work, simple treatments that do work, all through clinical trials, through systematic reviews, through meta-analysis. So a lot of us owe our good health to people like Paul, and Paul's been at the forefront of this for many years. So Paul, it's fantastic to welcome you here on a Saturday. I know you've driven up from the coast to be with us, but we are absolutely delighted to have you. So please make Paul very welcome. Just push that to go forward.
Thanks for that introduction, David. I'm not sure I can live up to that, but I have to say you were the best tutor I think I ever had teaching evidence-based medicine here when I was here. Is it now 30 years ago? So the place has changed. I did recognise a few of the buildings as I came through, but so much has changed. So as David said, I'm going to talk about what I think of as a very zigzag career. It's been a very interesting zigzag throughout that career. But I just thought I'd explain some features of it to give you an idea of what it's like as a clinician scientist, because I'm unusual in that I was a researcher at the time I was working with David, but then became a clinician again. So I'd been clinical, became a researcher only, and then became clinical again, and I'll explain a little bit of that history. And that was a very important part of my career. But you can also have a career purely having been a clinician, just as an epidemiologist, as an epidemiologist who does very important work on cancer or whatever else. So it's only one way. There are so many different paths you can take in this. So before I talk about my career, this is my warning first of all. I started my PhD in diagnostic theory and then went all over the place doing clinical trials, screening, acute respiratory tract infections, the evidence-based medicine part and monitoring part I'll talk a bit more about, more trials. Eventually got into this interesting area of waste in research, and I'm now working on systematic review automation to speed up the whole process of doing systematic reviews. Now I'm going to talk about it a little like the pictures that Mr. Squiggle, who you probably don't remember, or some of you might if you're old enough, Mr. Squiggle used to be given a few weird lines and then he'd draw this very good picture out of those lines. He could make a picture out of it that made sense. So my career might look sensible in retrospect, but it's really like Mr. Squiggle being given a few random lines to make a career out of. So this is the picture that Mr. Squiggle might draw about what my research strategy was now that I'm thinking about what it was like from the retrospectoscope. One of the things I should have learnt earlier is the need to focus on big problems. But you can't solve a big problem all at once, and I'll give you a couple of illustrations of that. You need to focus on the big picture, what's the big thing I want to solve, but then take small steps towards solving that. You want to document and understand the problem itself first of all, and preferably with the help of your end users, which is one of the valuable things about either working closely with clinicians or ideally being a clinician working in both places, the research and the clinical world at the same time. Learning from previous attempts on similar journeys, and something I wish I'd learnt earlier is building better tools. I was inspired about the building better tools things by the change in DNA sequencing, which I think was $1 billion or something to sequence the first human genome. And the cost has just come down faster than Moore's law of computing, which is it doubles every 18 months, or you can think of it as the cost halving. And there's lots of areas of research where we could be building those better tools. So whatever area you're going into, think about building those better tools. And my final, slightly odd one is keep your focus on that big problem. Be alert to interesting accidents. There's a great book on how a lot of discoveries were made, and a lot of them were by somebody observing an interesting accident. Warfarin, for example, was a guy bringing a dead cow to a bunch of researchers and saying, why did this cow die from red clover it was eating? And that's how they discovered warfarin, which now funds the Wisconsin University medical program. Okay, so by reconnecting with medical problems. So as I said, I'd done my internship, several years of clinical work, and then eventually did my PhD in decision sciences, about how to make decisions. Because I was really bad at making decisions. I wanted to work out how you learn how to make decisions. Turns out at the end of it, decisions are actually really complicated. Now at least I understand why it was difficult to make decisions. And then I worked in research only, in public health, in clinical trials, screening. That's some of the things that I'd mentioned. But then we had Dave Sackett. Dave Sackett was the founder and master of the evidence-based medicine movement. He didn't invent the term. One of his students, Gordon Guide, actually coined the term evidence-based medicine. But it was Dave who was the guy who really was the sort of inspiration for it. He worked in Canada at McMaster first of all, but then he moved to Oxford in the early 1990s. And this is a thing that we would now use a smartphone for, of course. He used to take a data projector and all of Medline stored on some CDs on a laptop computer with all of their previously answered questions on the ward rounds. So he used to have these long ward rounds where when clinical questions came up, they would do literature searches on the ward round and find out the evidence for things. And the average time it took them was 90 seconds to find the appropriate evidence. But as I've told people, they're the he and Sharon Strauss, who are doing this, were the Olympic champions of evidence-based medicine. Most people can't do a search and find the right answer in 90 seconds. AI might help us do that a bit faster. So Dave gave a workshop in Sydney and convinced me that going back into clinical work was really important, because he had been an epidemiologist, and 20 years after being an epidemiologist, he retrained as a physician. So I went back and started doing nights in the emergency department while I was still doing my academic work, and did that for several years. And then eventually I decided I need to specialise in something and retrained in general practice while I was doing my academic work. And I'm explaining that because my career is a bit different. Most people, I think, in clinician-scientist careers are a clinician who then learns about research. Mine was the other way around. I was already a pretty good researcher, but went back into clinical work. And this is a picture of me doing an evidence-based medicine workshop Dave Sackett was running in Oxford. Oh, fun too. So one afternoon we decided to go down to the Broad Street pub and run our clinical workshop session there. I then, when Dave retired, several years after he retired, in fact, I took over the Centre for Evidence-Based Medicine in Oxford from 2010. Oh, it says 1993, sorry, that should be 2003 to 2010. But I was a GP during that whole period, and then finally I returned to the Gold Coast as an NHMRC Australia Fellow. So I just want to explain a couple of examples of how this nexus between being a clinician, a GP, and doing the research work, how that evolved, how that worked out. So when I was here, working in the public health building just down here, but working as a GP at Anala, at the clinic here, I asked a series of people, physicians and GPs, what they use tests for. Because as I said, my research career started in diagnostics. And that's all that stuff that you really hated learning about in medical school, about sensitivity and specificity and how to do those terrible calculations. But I said, I'm sure we do use tests for other things. So I asked people to keep a log of the reasons why that they did tests. And here's the list. Diagnosis, monitoring, has it changed? Prognosis, to try and stage things, for example. Treatment planning, for example, cancer, you want to know where the cancer is and where are there metastases, etc. before you operate. For me as a GP, you might use it for locating a foreign body. And one particularly honest GP, Jenny Doust, said stalling for time. So this is an interesting research topic we've never actually explored if you want to take it up. Jenny really wanted to have a form that said there was a placebo test on it, serum rhubarb or something, and that you could write on it the number of days of delay that you wanted. So you'd say to the patient, I've just got to get a serum rhubarb on you, it'll take 30 days to come back. And you need the right amount of time to be able to stall for. Usually 2 weeks is the rule for most general practice things. So, never explored that one. I did explore monitoring though, because I remember a patient, when I was doing the GP locum, asked me, after I gave them checked their blood pressure and gave them the script, they said, when should I come back? And I went, 6 years of medical school, and I never learnt the answer to that question. And in fact, no one had worked out, so I just made up a number. I said, I'll come back in 3 months. Turns out the PBS allows you 6 months anyway, so that's your upper limit on when they could actually come back. But I've now subsequently learnt from work that we did on monitoring that it would be about a year, maybe 2 years, depending upon if you haven't changed any major condition like what treatment you're on. So the monitoring, the fact that it was second on this led me to think about that. And one of the things I'm putting here is that was in the 1990s. It was about 10 years later we finally produced this book on evidence-based medical monitoring. But it took me a long time to work out the principles of how you answer questions like how often should you test, which is the best test to use, how do you adjust therapy? And these were all questions in simple areas like hypertension that were not well answered because of the focus on the sort of pathophysiology of the whole problem. But the simple monitoring questions didn't have a systematic way of researching to find decent evidence-based answers. So that's what I did. But warning, if you're working in any new area like that, it often takes a long time. So, for example, when Graham Clark started work on the cochlear implant, it took him, I think, about 13 years to get there and had to do those little steps up the mountain in order to solve the big problem at the top. It takes a long time. Now, you're not going to wait 13 years to publish your first paper. So you have to plan out what those little publishable steps are along the way, what the little projects are that will get you up the mountain. Some of them will be wrong paths, so you might have to go backtrack and then go up another path to try and solve that big problem, but you have to be prepared to take that sort of time to do it. So in my clinical, that was an example where I was just talking to colleagues, which is a really good thing to do, and it's easier if you're working as a clinician to do that. But I worked both at a NALA and at a practice in Oxford. This is 19 Beaumont Street, where we used to hold a regular journal club. And for me, that was connecting the evidence work that I was doing, the research world, to the clinical world. So I used to keep a little logbook on my desk, on my clinic, of questions that I needed to record and look up answers to for the research. And then some of those things we'd discuss in my journal club here. This is a blind tasting we were holding, by the way, comparing margarine and butter, because we asked a whole series of questions. And one was, do plant sterol margarines lower cholesterol? The answer was yes, but people said, but what does it taste like compared to butter? So we had a blind tasting and butter won, unfortunately. I put up this list, though, for the highlighted ones because of my next theme that I wanted to jump to, which was, that again comes out of my clinical work, is looking at non-drug therapies. So David had mentioned in his introduction about the need to work with industry, but there's also a lot of therapeutic things that are actually non-drug. It's sort of, I would say, about half and half, at least for the tools in general practice. And particularly a lot of supportive care that we use in the clinic is based on non-drug treatments, the sort of physiotherapy type things. But here's a couple that we had looked at in my journal club in Beaumont Street. The other thing I did was in Oxford was to take over the evidence-based medicine journal, which we used to scan the world literature and look for things that were both valid and would change clinical practice. A guy called Brian Haynes at McMaster was really the brains behind this thing, but I co-edited the journal with him. So these were the things that really should change practice. They're both true. The research is very solid, high-grade evidence, and it's something that would be clinically important. And that turns out to be a very small fraction. Brian used to calculate the number needed to read And for most journals, the number needed to read to get one valid paper was 20, and to get one valid important paper was over 200. In other words, most journals, you could read most of the articles and never find anything that was useful. You really had to scan carefully to find it. Now, the thing I was interested in was I was editing this journal and I was implementing a lot of the stuff that was in it, but a lot of the stuff I wasn't. And so I asked myself, why aren't I using some of the evidence-based treatments that I'm advertising or picking up and describing in the Evidence-Based Medicine Journal? So Carl Hennigan and I, Carl's the new director of the centre, did this study where we asked, could you use this treatment with a patient tomorrow? And here's our analysis. Overall, the trials or the publication would allow us to use it about 50% of the time. If we wrote to people and did all sorts of things, we could up that to about 75%. But the things that were notable were that meta-analysis, because it doesn't describe one treatment, it's a sort of abstract category, is very poor, and non-drug treatments is also very poor. So that got me interested in this whole thing of non-drug treatments I couldn't use. So this was the interesting accident, by the way. I hadn't intended to ever research on this area, but stumbled across it and realised it was a big, important problem. So I wanted to start some work on it. And I just wanted to give you an illustration of the problem. This is in the BMJ, the TOHP study, the Trials of Hypertension Prevention. And in the paper that was published in the BMJ, that was the first study of salt reduction to show that it lowered cardiovascular events. Lots of studies showed it lowered blood pressure. None had actually showed it lowered cardiovascular events. Here's the description in the paper. It said individual and weekly group counselling sessions were offered initially with less intensive counselling and support thereafter specific to sodium reduction. So how do I prescribe that? So that's one of the ones that Carl and I said, you can't. But you could go back to this previous paywalled reference, and here's what it said, and you can read that. It's just, but when you read through that, you realise actually this is an incredibly intensive intervention with a nutritionist talking to people for 90-minute sessions over 10 weeks, measuring urine sodiums, giving them food diaries, all sorts of stuff. And even this you couldn't implement. You would need all of the materials that weren't again available in this paper. So it was unimplementable and it was also impractical, and I've still been looking for a practical method of getting salt reduction. It's actually probably salt substitution, which the George Institute's recently done a trial showing using potassium as a substitute probably does work, trying to get people to remove enough sodium. This is what it takes. Really hard to do. So that got me interested in, well, how do we get the non-drug interventions, because they're much more poorly used in practice. It's hard to get people to use the correct drugs and to adhere to them. It's much harder with non-drugs because there's no non-pharmacopoeia. So I thought we should have a non-pharmacopoeia. This is the Handbook of Non-Drug Interventions, which I started work on soon after that paper with Carl. It's showing that poorly described. The BMJ piloted it and decided eventually for commercial reasons they wouldn't proceed. But the College of GPs here decided they would pick up on it. We launched it eventually in 2013. So that was 10 years, again, that long period, after the Carl and my first documentation of the problem. And we've continued work on it. So 2 pieces here. This is some work that Tammy Hoffman and I did, looking at how well described, but in much more detail, what is it that isn't described in non-drug interventions. This was in the top 6 general medical journals. Overall, you could get 61%, up to 61%, but initially, just looked at the paper, it was only 40% had an adequate description that a clinician or another researcher could replicate tomorrow. So neither researchers nor clinicians could use 60% of the interventions that were being published in the top 6 general medical journals. And it was mostly the procedures and materials that was missing, was the major things, but a lot of little things. That led us to another piece of research. So these are the little steps up the mountain. And that was to look at developing a statement about how you describe interventions well, called the Tidier checklist, that was published a couple of years after the Handy had actually launched. So we started it without having that checklist, but we're now using that and it's been adopted by lots of journals. So it's been a long journey to try and solve this problem of better non-drug interventions. And that incidentally led me to yet another piece of research, which is about the waste in research, the avoidable waste in research, which Ian Chalmers and he's the founder of the Cochrane Collaboration, calculated as about 85%, part of it being due to non-publication, half the trials are never published, and part of it being due to this component. Okay, so to finishing up, coming back to Mr. Squiggle, it all sounds sensible looking back on it, about how you look at big problems and how you work out those small steps, but I had no idea that was the directions I was going at the time. So these are the things I wished I'd known at the beginning of them, but that's what my career looked like. But a lot of the influences that really changed the questions that I asked and how I went about those questions was the fact that I went back into clinical work. And so I acted as a nexus then between the clinical world and the research world. You can do it without clinical practice, but you then have to be very close to the clinicians who have those problems and work closely with them to understand those clinical problems. And I think that's right on time, David.
Absolutely. Now, don't go away. Fantastic talk. I love hearing about other people's careers and realising that squiggly lines are pretty normal, actually, for most people. That's fantastic. Before I open the floor to questions, your presentation made me realise that a key feature, I think, of your research has been your innate curiosity, always asking, why do we do that? Why is that happening? Can you tell me what you think about how much that might be needed for a career in research? Asking questions.
Yeah, I was an irritating child. Ask my mother.
Yeah. But
how much? It depends. I mean, there's such a variety of research careers, and so some of them, there are pretty straightforward questions to ask. You can be a good clinical trialist, and you're just good at running the clinical trials and asking the straightforward, clear next question to ask. Whereas my career, as you've seen, has been much more sort of zigzag and creative and innovative, and I've enjoyed that. And it's another type of research career. So mine is a particularly diverse, innovative, creative career, but they don't all have to be like that. Some people stick on the one problem their whole career life, and we need that diversity of different types of personalities. So, yes,
it's not one size
it's
fits
been
all.
an important part of my career, but I'm not saying it's an essential ingredient of every research career.
Very good, thank you. Any questions for Paul from the audience? And there are no dumb questions at all. Paul will answer anything you ask, because I will ask dumb questions otherwise. But very keen if people want to know what it was like transitioning from the clinic into research, back into the clinic. Maybe you could tell us how hard that was, Paul, going back into the clinic after having been out of it for a while. I would have found that terrifying.
I did, and I was actually looking at going back into general practice, and the woman I talked to at the college said, you might be advised to go back into the emergency department. It's scarier because emergency patients, but you've got much more support there. Yeah. So that's what I did. I worked at the Royal Prince Alfred in Sydney did nights on Friday night. Yeah. Very interesting time to do it. Yeah. And then at the Mater when I came back here to Brisbane. So it was scary, but the support was very helpful. Yeah. Then I had to decide I knew I had to have a serious clinical specialty, so that's when I did my general practice training, and that was a bit easier, having gotten over the hump of the scary bit of going back into practice. Yeah. And then I really enjoyed it. I don't think I could have been 100% clinician. I would have found it too boring to just be there in general practice, writing prescriptions and non-drug prescriptions, hopefully, all day. But the mix was actually very enjoyable. I used to like having the research time was great for the sort of creative, but as you know, it's very pressured as well. Clinic time is really interesting, but it's very confined as well. When you've seen that patient, they've walked out the door, that's it. You don't have to then put in a grant submission or chase a whole lot of people who haven't answered your questions about their CVs or whatever it is.
Serum rhubarb and said come back in 3 months. I've got a question here and then one up there.
Thank you. Awesome talk. I really enjoyed that. I think I'm in the camp of the people who always ask why and want to jump from one interesting question to the next. But I'm a researcher turned clinician, and I'm realising that a lot of clinicians are in the camp of we've always done it this way,
Mm.
and because it's hard changing practice. So can you share a bit about how to sway them towards trying the evidence-based approaches that they haven't before, and just your experience with this?
We need a longer talk. That's
It's his career.
Can I have a couple of hours?
No.
No, it's very tough to do. And I think you start with the people who are more open-minded and you find those people to work with first. Otherwise, if you can just knock on brick walls for a long time and you just end up with very bloody hands or foreheads or whatever you're knocking on with. So that's a sort of first start. And then building a network of people. And then when you want specific changes in practice, build the machinery for it. A really interesting model from Brian Nosek is he has this pyramid that first says, the bottom part of it is build the infrastructure, make it possible for people, then make it easy for them to do, then make it normative, and finally move up to make it mandatory. So for me, an example would be for the non-drug interventions, it was hard for me to do it. So that's why, being a clinician, I could test out, can I do this? I'm not going to tell, this is a Dave Sackett principle, never tell anybody to do something that you're not doing yourself. He held that very rigidly, and he actually stepped down from doing evidence-based medicine when a couple of years after he quit clinical practice because of that. So learning how, and then I discovered the barriers like building the handbook of non-drug interventions then makes it possible for others to do it. Otherwise, I'm telling them to do the impossible. So make it easier for them to do. So there's a sequence of steps. Brian Nosek's, basically he's turned the Rogers diffusion curve on its side to create this great pyramid. So if you look up Nosek, N-O-S-E-K, and he's the guy who developed the thing called the Open Science Framework. It's one of the best models I think I know.
There you are, you've condensed 3 hours of knowledge into 3-minute answers, so well done. And there was a question up the back, and then we might, this might be the last one, unless there's a burning one after this one.
In relation to publications not having good methodologies, or you cannot follow the methodologies written on them, that is a big problem, just in and of itself. So I was just wondering if you figured out next steps, or if you have an idea of how to overcome that, or how to change that, essentially.
Yeah, so I've been working on that problem for quite a while. So just to go back to the avoidable waste problem where I said the 85%, the problems were people not knowing what's already known. They didn't do a systematic review before you start a new piece of research because it's hard to do. So that's why I started on the automation of systematic reviews. We can now do a systematic review in 2 weeks rather than 2 years, which means it's now possible to do that. For the non-publication, the answer is going to be registration. So we don't actually have to publish all results, but you have to put your results in a registry, and that's now compulsory in the US for clinical trials. For the adequate descriptions, again, taking Brian Nosek's triangle, we need to make it possible, first of all. So that's the tidier statement. But what I'm now doing is trying to build tools to make it easier for people to do that. So we've got for systematic reviews, we've got a thing called the protocol wizard where you work through, guides you through the whole process, but it makes sure that you've got a PRISMA compliant protocol. We're now doing the same thing for clinical trials. So you've got your wizard that makes it much easier to write your protocol, but it will include the tidier template so that you fully describe your intervention. So it's really hard to get people to change, but if you give them a tool that makes it easier for them to do the right thing, this is a public health principle of make the healthy choices easy choices. In a sense, that's the first step that you want to do. Then you can start to push it and try and make it normative and persuade people to do it. But try and make it as easy to do first of all, make it possible and easy to do, then try and sell it to people. And that's what we're doing now with the methodological descriptions in papers.
There we go. I might close down questions. So Paul, thank you very much for sharing your career with us. And,